Hi guys, so this is our next video, and in this video what I want to describe to you is designing your experimental design. Okay, so a lot of times when we do an experiment, we complete the experiment, we write a lab report. So we write an introduction, we write a method section, we write a results, and we write a conclusion. And there is a video for that, and I'll be posting it fairly soon. In that particular video, I describe a lab report for the colorimeter or the kinetics experiment, the experiment where you use the colorimeter. But in this case, in this lab, at least on a couple of occasions, you're going to write a protocol for the experiment. You're not actually going to conduct the experiment. So what do I mean there? What I mean is that you have to use a graph or a microscope, a probe of some kind, to ask a question, provide an answer for that question, a hypothesis, and then design an experiment to test that hypothesis. So for instance, if we were going to use the colorimeter as an example, we could say we want to test how efficient amylase is under certain conditions, meaning amylase, the enzyme, how efficient is it, say, at 37 degrees Celsius when compared to 25 degrees Celsius. We can test that using the colorimeter by adding the amylase to the starch, heating that starch or cooling that starch before we add the amylase, and quickly putting it into the colorimeter. We'll get a graph, and we can compare the slopes of those graphs. So when you design a protocol, what's important is that you have a hypothesis. So in the example I just gave, your hypothesis might be that amylase will work better or have an optimal function at higher temperatures. So that's your hypothesis. You're saying that's what's going to happen. So how can you test that? You have to design something that would measure it. And you can use any probe. You can use any tools that you find in the laboratory. The microscope, the colorimeter, the CO2 probe, the oxygen probe, pH strips, pH scales, weight scales, whatever. That's the whole point. You have to ask the question. You have to answer the question, and you have to decide how to run the test. You do not have to actually run the test, so you wouldn't have any results and you wouldn't have any conclusion. The goal here is for you to begin to ask yourself, how can I measure in a way that addresses a question that I have about biological phenomena, what I see out here in the world? How can I test that to find an answer? Or more importantly, to support an answer that I have postulated, that I've hypothesized. So talk to your TA about this. Remember, they're going to have a rubric or a grading scale so that they have specific requirements. They are the people who will be grading your experimental designs. So make sure you know what they want. And I wish you all good luck. If you have questions or need assistance, do not forget about the Academic Mentoring Matters students who can help you. They've done this, and they can look at your design and give you some hints, or at least work through it with you so that you have someone who you know is really interested in making sure that you get a good grade. They're just as interested as you are. So remember, they're in room 106 of BO Hall or in the library after 4 p.m. And I wish you all a wonderful afternoon. I'll see you in the next video.